Wait a second, can I just say 34, 35, and just return A? Bro, I can have Python in my assembly. We can now do something like this. So we can say, okay, from 1 to 10, print hello world scheiße. And the message is, yeah, I can actually put whatever in here. And then I can actually have nice for loops in here, and it makes too much. Oh my god, are you serious? Alrighty, chat. So I haven't programmed in assembly for quite some time. I think the time has come to kind of refresh my assembly skills. Right, so let's go ahead and do that. So we're going to be using FOSM today, which is a flat assembler. I think I need to put that in the description just in case. I didn't think, yeah, I already put it in the description. Okay. So I'm going to go to maybe somewhere and create like a FOSM hello. Right, so let's create a hello world. So I'm going to create my main ASM. Right, so, and I don't fucking remember how to do that. There's a little bit of a bureaucracy involved into creating ELF files and stuff like that, so I do not quite remember how to do that. So let's actually try to do that on... Oh, okay, look at that. You don't even need to put any special instructions or anything like that. You can just create an empty fucking file, and it generated 0 bytes, and it actually... Okay, so... Who said that the first program has to be hello world? This is your first program, just empty file and empty file in, empty file out. You can, it even says bin or something. I think you have to specify like the format of the file you're generating. I don't quite remember. So can I just take a look at the, you know, at the files of FOSM? What kind of files do I have in there? So... Oh yeah, there is some documentation in here. Can we just fucking open this scheiße mine? So here is the official documentation. So do we have something like ELF 64? Oh, okay. So to select ELF output format, use a format ELF directive. The default code setting for this format is 32 bits. To create ELF file for the x86-69 architecture, use ELF format 64 directive. In such case, the long mode code is generated by default. Okay. So let's give it a fucking try. Let's give it a fucking try. Can I just fucking do that, mate? Oh, okay, look at that. So it generated more. 392 bytes. That's already something. I think that's pretty cool. So, and it actually generated an O file. But I think I want to have an executable, and I kind of vaguely remember that you have to put sort of like a execute. Oh yeah. So look at that. So it's even highlighted that. So, and I do have a FOSM mode in here, which specifically recognizes FOSM directives and stuff like that. So I suppose now I should be able to do this kind of shit, and it generated an executable. Look at that. Isn't that a poggers? I think that's pretty freaking poggers. But look at the size of this executable. It's 64 bits. Bytes, actually, not bits, bytes. 64 bytes, and I'm pretty sure I won't be able to even run this entire shit. So yeah, exec format error. It probably generated some sort of a garbage, right? So we can try to read this entire ELF thingy. This is not how you read. I think you do something like read ELF all, and it just shows you like literally everything, right? So this is a ELF 64. To complement the version 1, which never changes, it's always the first version. So OS ABI is a Unix system 5, and so on and so forth. It's an executable file, and so on and so forth. So as far as I know, you have to like create like a start instruction. Right, so you have to return out of that. So that's basically how you do all of these things. And it actually generated less, right? So it actually generated less. And now it fails with segmentation fault. Right, so before it failed with invalid exec format, but now it is a valid exec format and it fails with segmentation fault. Right, so and the reason why it does that is because we're trying to return here, and we return usually from the address on the stack, right? So return takes whatever is on the stack and just jumps there. Right, and since we have nothing on the stack, or we probably have some sort of a garbage, it tries to jump to the garbage, which is not readable, which is not executable. It tried to read it, it tried to execute it, and operating system, rightfully so, slapped it in the face with the segmentation fault. right? So that's basically what happened here. So essentially at the end of the program, we have to call like a, exit syscall, right? So let's actually Google up Linux x86 64 syscalls table. Give me the table. So the Chromium table or maybe some other table, I don't freaking know. So probably this one. Yeah. So essentially we have to put some number into the rex register. And the one we need in here is a sys exit. Yeah, up to 60. Yeah, I think I vaguely remember that. So let's actually move into rex 60. Right, and so there is different parameters in here. So it has one argument, which is error code, and that parameter goes into the register RDI. Right, so we move into RDI, and let's put 69 in there. And after that, you're supposed to put syscall. And since after calling the exit syscall, the program is going to be unloaded from the memory, there's no point in putting return in here. So it's basically this entire thing acts like a return back to the monkey, to the operating system, right? So let's try to maybe rebuild this entire scheisse, right? So, the size didn't change much, right? So, dozens of bytes. And if I try to, yeah, look at that. So it exited abnormally, but it exited with 69, and that was expected. That was basically expected. So this is a very simple assembly program, right? So which is like simpler than Hello World. Okay, you can go simpler than that. The most simple program is going to be this, right? So it's essentially like literally nothing, and it just generates 0 byte. The next one is going to be this, which is just a single exit code, right? So this is a level 2. So this is a level 1 assembly, this is a level 2 assembly. So we're going to be doing now level 3 assembly, which is trying to print something on a standard output, right? So we're leveling up slowly. Right, so I know that I already done this kind of stuff before, but I'm just trying to recover my knowledge, right? So because I haven't programmed an assembly for quite some time, and I kind of don't want to forget how to do that because I think it's important. So get some beats. Enumerate, thank you so much for 100 beats, and with the message, yo, I'm doing some awesome graphics programming right now too. We'll enjoy doing some recreation programming alongside ya, Mr. Azuzin. Thank you so much. Alrighty, so what's going to be the next thing? So the next thing is to actually call the syscall right? So let's actually go ahead and fucking do that. So let me see. So I'm going to move into Rex. Rex is going to be 1, right? So this is the 1. So then in RDI, we have to put the FD. So if I remember correctly, 0 is std in, 1 is std out, and 2 is std error, right? So that's basically how it goes. So that means if we want to print something into the std out, we have to put 1 in here, right? So this is basically FD for the std out. Then we need to put pointer to the buffer that we want to print. So, and it goes into RSI. All right, so let's actually maybe allocate that buffer somewhere here. All right, so and if I remember correctly, the thing to allocate some bytes in the memory was the db, right? So this is the db instruction or something like that. So let's actually take a look at the documentation. Do you have something like db? Look at that. Data definition, right? So to define data or reserve a space for it, use one of the directives listed in table 1.3. Right, so where do we have 1.3? Let's actually see. Oh, okay, so here they are. They look horrible. What the fuck is going on in here? Is there some white spaces bullshit? Yeah. Bro, mixing up tabs and spaces in table. The fuck is this? Anyways, right, so we need to reserve like a DB or file. Wait, you can have a file. Can I include file in here? What the fuck? I didn't know that, legit. This is awesome. What the fuck? Hello world. Right, so this is hello world. And so that basically takes the bytes of the file and embeds them in there. Right, do I understand correctly? So that's basically the thing. And so what's the size of the file? Right, so it's 13. So that means here, what I have to put for the RDX, right, so this is going to be RDX, it's going to be 13, right, and then I perform the syscall, right, so there we go. Let's actually try to, yeah, that actually compiled, and furthermore, let's actually open executable. Here it is. It literally fucking embed the content of the file. I can embed like automatically resources. This is already better than C. How freaking assembler is better than freaking C? It's just like more featureful. Excuse me. The fuck is this shit? So let me see if I change this thing to full bar, for instance, right? So here's the man, like, remember I wrote like a web server in assembly and shit, right? So to do awesome this thing, so I didn't know about that feature of embedding things, right? So, and for instance, for this specific thing, I was actually hard coding the responses and everything, and HTML and stuff like that. I can put that stuff into the separate file and embed them at compile time. I could have just put that into a separate HTML file. Like, I could have like a templating system that compiles stuff into assembly and everything. Right, yeah. This is so cool. Honestly, Flat Assembler is actually insanely based. It is insanely based. Right, so it has its own meta language, which makes it actually very close to C. By the way, right before the stream, I opened this website and I noticed very interesting, right? So very interesting thing. Website is powered by Raza. I have no idea what that means. Actually, I do know because I clicked that link. So let's actually click on it together. Right, so Raza is our full-featured, high-performance, scalable web server designed to compete with the likes of Nginx. It has been built from the ground up with no external library dependency, entirely in x86 64 assembly language, and it is a result of many years' experience with high-volume web environments. It is written in flat assembly. So just try to let that sink in, how much fucking based Flat Assembler is. Right, they serve their homepage from a server written in Flat Assembly. Just let that sink in. This is insane. Oh yeah, so it was developed by a Polish person, right? So Tomasz Grishtak. I hope I pronounced his name correctly. So yeah, this is actually super cool, right? It's an insanely based thing. So, and you may think it's just like, it's kind of difficult to develop this kind of applications in like purely in assembler. And as already said, Flat Assembly has a lot of cool meta programming features, and maybe they are actually extensively used in this server, which makes me kind of want to check this server, honestly. Let's actually check it, right? So can I download the source code of this motherfucker? So download. So yeah, download. All right. So can be downloaded from our products. They have products page. Did we go down? I didn't think we got down. Okay, so all right. So people pressed F or something, but I think it's fine now. Yeah, I think it's fine. So the standalone binaries here. Standalone binaries? I want a source code. So I don't give a shit about standalone libraries. Am I lagging again? I don't think I'm lagging. Alright. So maybe, alright, so let's actually restart the stream, right? So I want to actually turn off the VPN, right? So, alright, so looks like everything's fine. Cool, so let me double check that this thing is not banned in Russia. Okay, so, so source code, do you have a source code? Oh, okay, so a source code included with heavy thing. Assembly language library that is heart of two-tone digital. Okay, so let's actually download this thing. So heavy thing. So let's actually go in here and just want to see what it looks like. Heavy thing. Only 5 megabytes. How is that heavy? Not really that heavy. Packs, headers, and shit like that. Okay, so let's, so yeah, it does have its own separate folder and everything. All right, and all of this stuff is just, you know, headers. TUI geometry. Okay, so as you can see, they are actually extensively using the macro language, right? So this is definitely not assembly of in itself, right? So this is definitely some sort of a macro language. Right, so TUI geometry, various geometry helpers for our TUI goodies. This is mainly here for reference, though in some cases I do use the functions directly. Mostly the math is done directly in line. Right, so if use point new defined or defined include everything. Right, so this is sort of like new procedure. Prologue, epilogue, and prologue is probably some sort of a macro that is included somewhere. Right, so this is actually kind of cool. Right, so prologue, I'm pretty sure prologue is some sort of a thing. Right, so prologue and epilogue. Right, I'm really curious about what the fuck it is. If I try to grab prologue, yeah, prologue is literally used everywhere. And the question is, can I just like say, okay, define, right? This is not how you define new things. Right, but maybe you have something like it. Yeah, I don't really know how you define new things in here. So prologue could be either one of the macros that is defined within the source code of the server, or it could be a directive of FASM itself, right? So we can actually confirm or deny that hypothesis by just looking for prologue in the source code. There is no prologue in FASM, and we're probably not talking about the prologue programming language, right? So we're probably not talking about this kind of thing, right? So we're talking about like prologue, epilogue, and so on and so forth. Usually in the low-level programming, prologue is just like a boilerplate that is happening at the beginning of the function and stuff like that, right? So that's probably usually the thing in here. Right, so that means it is defined somewhere in a different place. And maybe it's a macro, right? So how do you usually define a macro? Macro instructions. Okay, so here is the section for macro instruction, and the section is 233. So, okay, so it's probably defined as macro prologue, right? So that's probably how it is defined somewhere, right? So it has to be macro prologue, and there we go, I found it. I fucking found it, and this is how it's usually done. So let's actually try to see what exactly it does. Right, so it creates a bunch of local, I presume this is a local labels, right? So because usually the labels that start with dot are the local labels. It's sort of like a common meme among assemblers, right? So if public func is true, oh, this is actually kind of cool. So you probably have some sort of a global directive that controls whether all of the functions are public or not. Right, all of the functions are public or not. And the public function in FASM, if I remember correctly, is basically the function that is sort of like exported. Right, so for instance, here is my hello world, and I can take a look at what kind of symbols it exports. As you can see, there is no exported symbols in here whatsoever. Right, then if I say that, for instance, start is public, right, so if start is public, and try to build FASM main ASM, right? So illegal instruction, you can't really do that. Okay, so, but I remember that there was like a way to say that something is public, or maybe this is needed for just general format. So this is a final executable format. If I don't make it executable, yeah, look at that. So I didn't make it executable, so it created an O file for further linkage, and then if I take a look at the symbols that, okay, there you go. So it exports start, right? So that means if I create a library in assembly, I have to mark certain labels as public, so then the linker can actually link them with the program that calls to those labels and stuff like that. Does it make sense? Right. So it's essentially like a non-static function in C, right? So that's basically what it is, if I remember correctly how FASM works and shit like that. Right, so and for instance, if I remove public from here, right, so if I remove public from here, I think it will not appear anymore if I try to compile this entire thing. So we can take a look at symbols, and as you can see, there's no symbols in here. The output is absolutely empty. Right, so but in a final program, I don't really want it to be a library. I want it to be an executable thing. So here is the profiler, and here is the very interesting thing. The prologue is defined in a profiler.inc, so it probably puts some profiler shit into each individual function. That is very cool, right? So, because it's a very common thing, right? So in a big application where you profile and care about performance, you usually have a little bit of a boilerplate for each individual function that inserts some stuff for profiling, right? So, and because of that, the prologue, the thing that is put into each function is defined in a profiler. So basically that's what it does. So there is some sort of a global macro which defines whether this thing is going to be public or not public, and it marks that specific name with public or not. Right, that's basically what it is, and it just like does something for each individual function depending on some sort of a global configuration and everything. This is actually kind of cool. Honestly, this is insanely based. I really like that. So it marks some default local things, and here they are. It uses them, and I wonder. So here are the labels. Here are the labels. Very cool, very cool. So yeah, I really like this server, right? And it's entirely written in this kind of style, and it's explorable, right? So I just saw some sort of a macro, and I was able to figure out how to, like, you know, what this macro does, right? So prologue macro, it's very easy to find. Yeah, so it's pretty readable. It's pretty cool. Yeah, and it's a server. It's all cool, but not portable. Well, I mean, it's portable within x86-64. So essentially, maybe you can port it between different operating systems and stuff like that. I remember there was an interesting thing, FASM2, right? So the idea of FASM2 was that we're going to have such a powerful macro language that the specific platform becomes irrelevant. So essentially, the macro language allows you to create your own instructions that generate their like very specific bytes in the final output. So, and essentially, different architectures and different processors becomes basically different libraries. So yeah. But I don't know how much developed the flat assembly 2 is, right? So it's been a while, it's been in development, but the idea was that eventually, like, the specific CPU, the specific architecture that like just doesn't mean anymore, that doesn't matter anymore. FASM is so good, we got FASM 2, yeah, exactly. FASM 2 as a language backend, yeah, it basically turns it into a language backend, essentially, doesn't it? All right, so let me see. So let's continue maybe developing this thing. I think I want to be able to automatically sort of like compute the size of this file, right? So because I recently changed it, so it's now 13, but it should be 8, or actually 9, including the new line. So if I remember correctly, there was some sort of like an instruction, I think EQU, right? So EQU. Honestly, I really appreciate that the author of this documentation actually wraps all of these directives in quotes. It makes it very easy to search and grab. Right, so it's actually very convenient. I never thought about it. So, okay, so we define it like this. So let's actually read what this thing does. Symbolic constants, right? The symbolic constants are different from the numerical constants. Before the assembly process, they are replaced with their values everywhere in the source line after their definitions, and anything can become their values. Okay. Before the assembly process, they are replaced with their values everywhere in a source line after their definitions, and anything can become their values. The definitions of symbolic constants consist of a name of the constant followed by EQU directive. Everything that follows this directive will become the value of the constant. If the value of symbolic constant contains other symbolic constants, they are replaced with their values before assigning this value to the new constants. For example, D becomes D word, null becomes D0, right? Whatever. So the reason why I need this directive is because I want to define something like hello len, which is equal to current address, the current address where this entire thing is located, minus the address of the hello, right? And that should automatically basically create the length of this entire stuff, right? So if I try to now build this entire stuff, so undefined simple, do I have to do it like this? Just a second. No, it's a legal instruction. Huh, that's very interesting. So it doesn't like it like this. So move RDX undefined simple hello. Is that because it has to be defined like before like this? Yeah, looks like it has to be defined before like this, otherwise it doesn't work. I remember being able to actually define it like before, like after that, but maybe this is because I was actually using separate segments and everything. So, okay, so if I try to now run this entire thing, it does a segmentation fault, right? It does the segmentation fault. You know why? You know why it does the segmentation fault? Probably because, so does this, oh, maybe I have to do db. Maybe you forgot db. Maybe I did forget db. Do I have to do something like this? Maybe I have to do something like this. Just a second. No, I didn't think so, actually. Right, it's not about db. It's about that. Anyway, so you know why it fails? You know why it fails? Because it probably starts the execution from the top of the file. Right, it just like follows this entire thing and it generates the final assembly and it just executes it from the top of the file. What we have to do in here, I think we have to say that the entry of this thing is start. Right, so you have to explicitly say that, okay, so that's pretty cool. Right, so, and it printed foobar, but it actually printed extra garbage in here. And I wonder why. And it exited with the code 69. Do we still exit with the code 69? I think we should start exiting with the 0 code. We still printing 60, like a 69. Right. So yeah, probably maybe equals, but I'm still curious why this works and why it prints the way it prints. Right, so what the fuck is going on in here? Right, so what exactly is going on in here? So it has to be something like this, but if I do something equal, all right, so maybe it has something to do with, oh, I think I understand now. We have to actually read this entire thing more careful, right? Because hello len is substituted with the content of thing after equal. So that means it is physically substituted with this. So that means it will print the hello plus a bunch of instructions up until here. So that's how it works. That's the main difference in here. Instruction, yeah, instruction leaked essentially. That's really funny. That's really interesting. So we can even try to confirm that. Right. So if I, yeah, it's literally the same output. I can even remove that. Yeah, it's literally the same output. So this hypothesis is correct. All right. So and essentially we have to use equals, and I suppose the difference between them is the equals is a numerical constant, right? So this is a symbolic constant, which substitutes the symbols, which makes sense. Holy shit, it makes sense, right? So that's why it is called symbolic, because it literally stores the symbols Right, so it's like C macros and substitutes the symbols. It's like a hash define. Right, but the numerical constant, they evaluated at compile time and they contain numbers. So there should be a section about numerical constants. There you go. So there's a conditional assembly and stuff like that. So numerical constants, let's actually read about them. Here they are, equals. The equals directive allows you to define the numerical constants. It should be preceded by the name for the constant and followed by the numerical expressions providing the value. The value of such constants can be a number or an address, but unlike labels, the numerical constants are not allowed to hold the registers-based addresses. Besides this difference in their basic variant, numerical constants behave very much like labels, and you can even forward reference them. Oh, okay, so that means that allows me to do things like this. Right, so because I'm forward referencing them, so they kind of behave like labels, and I can forward Holy shit, this is so educational actually. This little file in here is very useful. I'm really glad that the creators of FOSDEM actually provided this file. 5,000 lines of code, holy shit. Okay, so this is actually super cool. So yeah, I can have numerical constants, and ooh, that's very interesting. So I can even reassign them. Is that what you're trying to tell me? Wait a second. Can I just say 34, 35, and just return A? Bro, I can have Python in my assembly. What the fuck? So this is so cool. Holy shit, this is so based. So compile time Python. Python, yeah. So that's so freaking cool. I never realized that. Okay, and here is the kicker. Guess what FOSDEM is written in? Guess what this little thing is written in? You think it's written in high-level language like in C and C++ or Python and stuff like that? You think it is written in Python? You really freaking think it is written in Python? So is there like a source code somewhere? Right, so it's for Linux. So flat assembler GitHub. So there's a GitHub page. This motherfucker is written in itself. It is self-hosted. It is fucking written in itself. I'm not even joking. It's insane. This thing deserves thousands of stars. Like, why this thing doesn't have like a 10,000 of star? Seriously. And like yet another shitty framework that is going to die within a year, it has like a 20,000 of stars or anything. This thing being absolutely fucking cool. It doesn't even have thousands of them. That's basically the state of tech today. That's literally the state of the tech today. So anyway, give it a star. Definitely give it a star. We must show these goddamn tech grifters what's the real tech. So yeah, I'm gonna put that in the description as well. All right. So that's pretty cool. So we can have hello world and stuff like that. What else can we do in here? We can try to maybe, I don't fucking know, like print hello world several times. Right, so right now we're printing it only once. So here is the exit code. We have to put 0 in here. So full bar. And the coolest thing is that, yeah, I can actually just put whatever. I can actually put whatever in here, right? And it's going to work. That's pretty cool. So essentially, what we need to do, we need to repeat it several times. So the easiest way to repeat it is just like jump back to the start. Right, but in that specific case, the application is never going to finish. Right, so we need to basically print this thing limited amount of times. Right, but the question is like, we need to have some sort of a counter. We can store the counter somewhere within the register, right? So, but we're constantly using the registers. Right, so can I just like move something in RCX? All right, so if I put RCX, for example, 10, then I call syscall. Is it going to be overwritten or something? Because as far as I know, RCX is kind of a part of the arguments. No, it's actually not part of the arguments. Right? I suppose we should not use any of these registers, right? So because the kernel can sort of like override them, right? But RCX, I think we can use RCX. I think we can actually use that. And by the way, I think I want to put this entire stuff into the description. I think it's going to be very useful. Okay, so, and what we want to do, we want to actually do this kind of stuff. We want to repeat everything while RCX is greater than 0, right? So we can compare RCX to 0, right? And that usually sets the flag registers to a certain way, right? So, so essentially it acts like, I think, RCX, yeah, so maybe it subtracts this one from this one. But that enables us to use certain instructions, right? For example, jump when less, right? Less or equal, right? So we do comparison to 0, and then we can say jump when less or equal to 0. And where we can jump to some sort of a label which is over, right? So it is over, and it is over somewhere here. There you go. So essentially here we have a little bit of initialization, and here is the condition, right? Here is the condition, and here is the body of the loop. And by the way, I feel like the beginning of the loop has to be not at the start, right? Not at the start, but somewhere here. Right, so we can say something like again in here, and here is again, right? And this thing also has to be a local label, right? That's basically it. So do you guys know what's the deal with local labels and stuff? You guys know what's the deal with the local labels? So non-local labels are just the regular labels that don't start with the dot, and the local labels are the ones that start with the dot, right? And the thing about the local labels is that their name is actually not that. Their name implicitly includes the first non-local label above them, right? So the real name of this thing is this, but it's implicitly omitted. So why do you need that? You need that so you can have several local labels in several separate functions, right? So I can have a function foo, and I can use the again label within that function foo again, because its real name is actually not .foo, but foo again. So they're sort of like namespaced. They namespaced by the first like upper non-local label. That's basically what it is, right? That's basically what it is. Okay, so this is what we can organize, right? This is what we can organize, and we can now try to maybe run this entire thing, and it still doesn't work properly. So did I recompile this entire thing? I think I did in fact recompile. Okay, so another thing we can do with our assembly program actually is to maybe debug it, right? So there is a special instruction int3, right? So which is basically seek trap or something like that. So if you try to run it as it is, right? So it's a trace breakpoint trap, right? That's what it is. So now what we can do, we can actually try to run this entire thing in a debugger, right? So I'm basically running this entire thing, and it obviously fails at that specific instruction, and then I can disassemble this entire thing, and there we go. Here is the assembly that we have in here. Right, it looks like shit because it's not an Intel assembly, right? So it's AT&T assembly, like objectively inferior style of assembly. Right, I don't remember how to actually set it to, you know, to Intel assembly. There was some sort of a way to do that. Toggle assembly set disassembly mode. I don't quite remember how to do that. I know the GDB has an instruction, but also GF2 had something like that. Right, so let me actually see GF2 next. GF2 next. Set disassembly flavor into blah blah blah. I know GDB has something like that. I already said that. You didn't listen. What I'm saying is that I remember that GF had something like that, or did it? Oh, apparently it did not. Okay, okay. So you really do need to depend on the GDB mechanisms. Okay, so we can actually try to do that. And so that means, oh, there we go. So that actually kind of works. So why don't I have db gdb init? Right. Why don't I have that in my dot files, chat? Right. Why don't I have that in my dot files? This is actually kind of weird. I think I should add that to my dot files, chat. I think I should do that. So okay. So let me try to restart the whole thing. Right. So we're gonna go in here and GF2. Right, so then I'm gonna run this entire thing, and yeah, it's a proper assembly style. Proper assembly style. So how can I add this entire stuff to my dot files? Right, so let me see. Here are my dot files, and let me go to here. So here is the db init. I'm gonna put it in here. So I have some sort of like a custom, not really store, but kind of like a custom symlink manager, right? So, and essentially, it's based on the manifests, and manifests tell you how exactly you map the file in the Git repo to the symlink in the home folder, right? So essentially, it has a script deploy, right? And you're supposed to do deploy manifest Linux, right? So when it goes through the files in the manifest and tries to symlink them and tells you that some of them are already symlinked. So what we have to do in here, we have to say that gdb init, right? We have to symlink this thing as it is, right? So you can actually redirect where exactly you want to symlink a particular file, but you say that you're going to symlink it in here. You can also comment out, right? So you have to actually look it through the conf, right? So you can say, don't symlink this one, right? So, and then I say, okay, deploy, and as you can see, it picked up this particular file and it symlinked it into here. Right, so that's basically how it works. And it's a custom file, a custom script, which is actually super simple. This is the entirety of the script. It's 55 lines, right? It's literally 55 lines, which just parses the manifest file and just symlinks and just manages and stuff like that, right? So super simple. You can find this entire thing in here if you're interested, right? So I'm gonna put it in here. And for people on YouTube, it's gonna be in the description. Like this in the description. Alrighty, so that's pretty cool. So because I think I'll need it on all of my setups, right? So I'll need it on all of my setups. So what the fuck is this? Alright. Fucking shilling their Discord servers in the chat. Okay. Now, yeah, so let's actually debug this stuff. What do we have? Fuzum. Where was the main asm? Right, so here's the main asm and GF2. Let's run it. And now, if I take a look at that, I wonder if I can actually increase this side. Right, so let me see what is going on. So we can even take a look. Can you, by the way, see? Right, so because I feel like the font is kind of small. I think the font is kind of small, and I remember there was a way to kind of increase this kind of stuff. Right, so, all right. So I think I want to increase that because, I mean, maybe for some people it is good, right? But for the stream, I don't think it's that good. So there is some sort of a settings, right? So, okay, so we can actually increase. Aha. So on startup settings are loaded from config gf2 config ini, follow that project gf. So we probably want to create this specific thing, right? So let's actually go to config, right? So, and I'm going to put this stuff in here, and we are going to just scale the font by half. Right, so this is what we're going to do. By the way, for those who doesn't know what kind of like a config, you know, front end we're using GF by Next. I really recommend to check it out. Right, so, and in here, right, so I suppose I'm gonna also put that in the description for anyone who's interested. All right, so now if I try to maybe take a look at that, GF2, did it even increase the size? I think it kind of did, but it not too much, right? I don't think it increased the font. It just make other things bigger, right? Freaking. Look at that shit. It didn't increase the font, but it just like made the elements bigger. Well, I guess that makes sense, right? So it's the scale, but not really the font. So said, yeah, I know that. Look, I mean, Jesus fucking Christ. Thank you for the advices in a hindsight. Right, it's very useful advices. When we already tried the scale and it didn't work, it's very fucking smart to say, oh, you actually try font size. Thank you. Anyway, why am I even reading chat? I don't fucking know. So we'll get some subs. I better read subs, right? So subs are really better. So thank you so much, 10% Delta for tier 1 subscription with the message. Holy shit, it's been a long time since I last caught a stream of yours. Thank you so much for the sub. 21 Lux, thank you so much for Twitch Prime. Do you feel that Phasm macro magic? Yeah, I do feel it. I actually do feel it. It's actually super cool. So the macros of Phasm are really powerful, right? They basically turn Phasm into the language that is more powerful than C. And this is probably why people implement all sorts of crazy shit in Phasm, right? Like, for example, web servers or operating system. There are operating systems in Phasm, right? So I think it's like Phasm Menuet OS. I forgot how it's spelled, so I apologize for... No, yeah, this one. So it's implemented in Phasm, right? So, and it's actively developed, right? So the last change in like 2024. Maybe we should look into that at some point, right? So let me actually put that into the chat and for other people and stuff like that. Right, so here is the description. Here's the description. So Yusu. So Raxla, thank you so much for gifted subs. Sandy X, thank you so much for tier 1 with the message a section dot text code readable submissive breathable executable. Yeah, I remember that. So because you're supposed to like put all of that stuff into sections, right? But I think sections are specifically for linking, right? So in ELF, there's two notions that are segments and sections. Who knows what's the difference between segments and sections? These are two different things in ELF, right? These are two different things. If I remember correctly, and I might actually confuse them, one of them is runtime notion, another one is a link time notion. I think segments is basically the chunks of code and data that are defined at runtime, right? So basically the ELF tells to the kernel, okay, so here are the segment with these permissions, here is the segment with these permissions, put them in the memory somewhere or maybe at these specific places with this permission, and the kernel will do that. Sections, on the other hand, right, sections that they had are sections of code for link time, so they are for the linker, right, to put them in place and stuff like that. And they could be loosely correlated to segments in the final executable, but not really, right? So yeah, it's kind of weird, right? Segments is runtime, sections is link time. So, and I don't remember, maybe I actually confused them, maybe it's the other way around. But the only thing I know is that one is runtime and another one is link time. So, and yeah, so you can actually specify different permissions for them, like readable, writable, executable, submissive, readable, and so on and so forth. Anyways, Jankoi, thank you so much for Twitch Prime with the message. Yo, 3-month anniversary. Thanks for the funny code magic, man. You're welcome. You're welcome. CodeCat69, thank you so much for tier 1 with the message. 15 month, I guess. 15 month, I guess. Thank you. Thank you so much. Ajakix, thank you so much for tier 1 with the message. 30 years. 30 years indeed. 30 years old boomer. All right. So Yesu. Okay. So what we were doing, I think we were, yeah, so we're trying to increase the size and stuff like that. So can I just remove the scale? Can I just remove the scale? All right. So GF2. Now it is better. Now it is better. So that's pretty cool. So we can see better. But I feel like along with that scale, having scale would have been nice as well. And honestly, it would be nice if there was one scale that just scales everything simultaneously, both UI and the font, so you don't have to think, oh, I scaled the font, but now these squares are too small, so I need to scale the UI now. Can I just scale everything? Right, so when I press Ctrl-Shift+, I don't think whether I scaled text or scaled the rectangles or anything. I asked scale everything. Like I don't have to think about scaling individual elements. Like it doesn't make sense from the UI point of view. You know what I'm talking about? Right, so if you want to scale things, you want to scale UI, you want to scale the whole deal. Right, so separating different elements of the UI, like I don't care. I just don't see shit in this means, just scale everything. So yeah, that's kind of weird. Right, so it's not built on top of Chromium. How does that have anything to do with that? Why am I reading chat again? Anyway, so I'm gonna be reading only subs because they say smart things. Okay, so thank you so much 86D for Twitch Prime. Thank you. Anyways, so it's not particularly convenient, right? So I think it should be like a, you know, common thing that scales literally everything. Where is my stuff in here? Where is my stuff in here? So GF2 and everything is scaled. Okay, let's go. Let's fucking go. So that's pretty cool. And now I want to take a look at the registers and what do we have in here? I have to actually step with instructions. Okay, so as you can see, we put 10 into the RCX. Right, so then we compare the RCX. There should be some sort of flags in here. Right, so here's the E flags, right? So, and they're set to, I don't remember which one is that, PF and EF. I should probably look that up, but I'm pretty sure that means that it's not going to jump over, right? It's not going to jump over, so it's just going to fall through. And we're just about to call the syscall. I can actually put whatever in here, so that makes sense. And I think I already realized what kind of mistake I made in here. I didn't increment RCX. And RCX is, okay, so you can't really put that shit into RCX, right? So it overrides that thing. It definitely overrides this thing. So we'll probably maybe want to put that stuff into a register that is not affected by anything. For example, R15, right? I'm pretty sure R15 is not really used. Yeah, so as you can see, it's not really used by anything in here. R11 is used, but yeah, anyway. So let's go ahead and just like use R15 for this stuff. Ideally, you know, I feel like it has to be maybe located somewhere in the memory, right? So it has to be some sort of a slot in the memory that we constantly read into the register, just check things and then like write it back and so on and so forth. Right, anyway, so we check if it's 0. Then after that, what we have to do, we have to decrement R15, right? So, and that will eventually turn it into 0 or negative, and that will allow us to go out of the loop, right? So hopefully, right? So let's go ahead and just try to maybe do this kind of stuff. And I forgot to remove the instruction in here, right? There we go. And it printed it. It should print like 10 times actually, right? And in fact, it printed it 10 times. Look at that. We organized the loop. We actually organized the loop. How about that? Isn't that poggers? Isn't that poggers, meine Freunde? So today doesn't work, or what? So did you debate me? You probably debated me with some Cyrillic letters or something like that. Anyways, so yeah, that's pretty cool. So we can organize this stuff in here. That's pretty boggers. That's pretty boggers indeed. I think I'm running out of tea, chat. I'm literally running out of tea. So we probably, it would be kind of cool to also print the numbers themselves, right? Print the numbers. I had a very cool function in Porth, I suppose. Do you guys remember Porth? I think it's somewhere in GitLab, it's sodding Porth. Right. So I had a pretty cool function in Porth. Let me actually see. I'm gonna put that stuff in here. I had a pretty cool function in Porth that just printed a number, and let's view it raw. Here it is. This is a very cool function. So what it does, I think in Rax or RDA, I don't quite remember. I think it was in RDA. It takes the number from the register and just prints it on the standard output, and it just like renders the number using the stack, right? So it allocates some memory in the stack, it renders the number into the stack, and then just prints it on the standard output. So the way I created this function, I actually generated it from C code, if I remember correctly. So I wrote this function in C, right? I wrote this function in C, then I compiled it down to assembly, right? And then I just copy pasted it into my code, right? So, and then just used it. So it was actually kind of cool trick, right? So maybe we can actually take that stuff. Right, so can I just copy paste this entire function into main wasm and just maybe put it somewhere here, right? So I think it also puts a new line in there, but I don't quite remember. If it doesn't, you can always put it there. Does it use R15? I don't think it uses R15. Nah. R15 is a really rare register that nobody really uses, so it's relatively safe maybe to use it for counter. But in any case, so let's actually do something like that. And I don't remember what registers you have to put it into, right? So we initializing this thing, we allocating 40 bytes on the stack by subtracting RSP. Then we move we move the counter into the thing, right? So then we just load some stuff into RCX. And I suppose you have to put the number into RDI. I think that's the thing. So I think it's passed through RDI. So if you want to print something, you have to put it into RDI. So what we can do in here, let me comment out this entire thing, and I'm gonna basically do the following thing. Move RDI 69 call print, right? Will that print 69 for me? Yeah, it did. Look at that. It actually printed 69. So this function is capable of just rendering the number and printing it. So that means I should be able to use it the following way. So the counter is R15. So essentially what I do, I move R15 into RDI and I call print, right? So, and it shouldn't, override R15. It doesn't really use it for anything. So that means it will basically print starting from 10 to 1, right? If I understand correctly. Yeah, there we go. So this is basically what we have in here. And we don't even use the standard library of C yet, or at all. We could have actually used standard C library, I think. We could have used it, but I don't really want to use it. So now we can print numbers, which is actually kind of cool. All right, so we can actually print them maybe in a different order, right? So we can say, okay, so let's start with 0. We can compare it to 10. And if it's greater or equal, only then go to over. So that means it's going to go from 0 to 9. Well, I mean, what it's supposed to do, I'm supposed to increment it, not decrement it, and there we go. So it goes from 0 to 9. So this is basically a for loop. I wonder if you can actually wrap this for loop into some sort of a macro. You know what I'm talking about? So can I create a macro where I can say, okay, so here is my variable somewhere here. I can allocate variable I, which is, let's say it's a DQ, right? So it's a quarter word. And it's initially 0, right? So and then I can say, okay, use this variable as the counter and count up until there. That would be kind of cool, I think. Right. So and it will just expand to this thing, and maybe you should be able to provide like a body. To be fair, honestly, listen. This is the beginning of the for loop. This is the end of the for loop. You can basically tag that all of that away into a macro. You can basically do that. It's not that hard. So that's actually kind of cool. I need to learn how to do that. And it should be that difficult because we have lots of examples, right? So we have lots of examples in the web server, in the web server. For Prolog, yeah, it's kind of like that. It's definitely going to be a macro. We can take a look at how you create macros in there, right? So here's the macro instructions, and here is the section, right? So yeah, macro directives allows you to define your own complex instructions called macro instructions, using which can greatly simplify the process. But I don't want to create a macro instruction. But I mean, technically, it is kind of a macro instruction. So is there any other kinds of macros? Repeating macro instructions. Right, because I want to kind of have a body or something. Repeating macro, yeah. So what is the repeating macro instructions? So the repeat directive is a special kind of macro instruction which makes a given amount of duplicates of the block enclosed with braces. Okay, so you can just basically copy paste this sequence of instructions like n times. All right, but this is not exactly what I want. Yeah, so you can just like repeat this thing 3 times or something. Right. Anyways, it would be kind of cool to have this sort of like a macro, but I mean, not quite sure. Like, will I be able to nest this kind of macro? Right, so because the macro definitely has to create some sort of a label in here, and then the other macro, definitely going to be 2 macro instructions, right? So the beginning of the for loop and the end of the for loop. And so this one creates a new label, and this one should use the label created by this macro. But then what if I want to nest them? So the labels are going to collide. Right, they're going to collide, so what exactly do we even do there? So this is a very interesting question. And furthermore, so where's the profiler stuff? Let me find the prob heavy thing. So there was a profiler inc, and let me take a look at the fuzzer mode. Let's remove that. So here's the prologue. So you can create a macro like that with the name and shit, and also they create local think. Why do we have to mark them as local in here? What does it mean? Is that some sort of a special thing? Does the documentation even say anything about that? Yeah. Local directive defines local names which will be replaced with unique values each time the macro instruction is used. This is the answer. This is the answer to that, right? So essentially, if they're nested things, right, so, okay, this is actually kind of cool. So that means it will kind of generate like a new unique name for this thing. Damn. But if closing the loop, and this is the problem, if closing the loop is going to be a separate macro, how do I make sure that it's going to use the right instruction? So that's the real question in here. That's the real question. Because I think prologue and epilogue are kind of like that. So, but I'm not kind of sure. But epilogue doesn't even use anything in here. So I want to be able to pass like blocks of code into a macro, like a blocks of code. And because I want to be able to pass a body for the loop. Right, so that's what I want to be able to do. I want to be able to pass a body to the loop. So then I can define what goes at the beginning and then at the bottom. Wasn't the repeat macro doing that? Repeat macro was copy pasting the body, if I remember correctly. It was copy pasting the body. It wasn't doing what I want. All right. So macro instructions 233. Okay. So maybe there are some examples in here. Here's the macro. Okay, that's understandable. So macro align, that's understandable as well. So this is a special move, right, which, oh, this is actually kind of cool. So you can check if the operand is one of these registers and this operand is one of these registers, you actually replace it with a different kind of instructions instead of move. Right, so this is actually kind of cool. So here is the another macro. There's a lot of text in here. And so what is a char? So enclose group of argument declaration. If after macro directive you enclose a group of argument declaration in square brackets, it will allow giving more values to this group of arguments when using that macro instruction. Okay, so this is variadics. You can have variadics with the macros. That's cool. Right. So is there any special macros that are sort of like accept the body? That's what I'm looking for. Inside macro has multiple values, common std call. So, it accepts labels, for instance. You can specify labels. Which is useful sometimes. Okay, that's understandable. So there's a tilde in here. Don't really understand what's up with that. So there's a message argument, nothing particularly interesting. Extending instruction. So, ooh, what is that? Is that what I think it is? Is that what I think it is? Wait a freaking second. Ooh. Ooh, or not. The another technique for defining one macro instruction by another is to it's a defining one macro instruction by another. Not really what I wanted. Okay. Structures. Okay, I think it's not really possible to do it like that. Right. So what I want to be able to do, I want to be able to pass like a body, but I don't think it's possible. So very annoying, but it is what it is, and it isn't what it isn't, so I don't know if we can do anything about that. Anyways, so I think I want to make a small break. I want to refill my cup of tea, and after a small break, I suppose we're going to continue exploring the beautiful world of FOSDEM. So, alright, so let's fucking go mine further. So what I'm thinking, let's try this kind of shit anyway. Let's introduce a macro for. Is for, yeah, so for doesn't seem to be a keyword in FOSDEM or anything like that. Let's just introduce for. And let me see, so macro instructions 233, something like that. This thing will give me some stuff. So what I'm interested in is, I suppose, an address, right? So it's going to be an address of a variable of the counter, right? And then, so in here we either jumping, right? So there should be like again and over things, right? There we go. So we're gonna pass both the counter and both labels in here, which is kind of dumb, but that's what it is. Right. Right, so it's like it doesn't solve any problems, but there's nothing I can do about it. And what's funny is that this is a part of the AND, and here we also have to put both the labels and the counter. Right. The label and the counter. So, and to be fair, in terms of the counter, I would like to maybe use the actual thing in here, right? So essentially, what do? We need to move into the address I0, right? So will that compile? FOSDEM, so that didn't compile. Operand size, so it has to be keyword. It has to be keyword. There we go. Right, so we initialize this entire thing. So the next thing we have to do, right, and that was the initialization, I suppose. Right, inside of this thing, can I directly compare this value? Is that something I can directly compare the value inside of this thing? That is very cool. And then in here, can I increment the value inside of this thing, or do I have to first put it into a register? I can directly increment all of that stuff. Okay, so that's very fucking cool. So what that means, and by the way, let's actually try to run the whole thing and make sure that it seems to be working. No, apparently I can't do shit. Fascinating. So why the fuck didn't that work? Oh, because I was printing this stuff. Okay, that makes sense. Sure. There we go. So that works now. Right, I wasn't moving this kind of stuff into RDI or anything. Okay, so now we need to create a macro in here. So let's copy paste this kind of stuff. This is going to be the address. Might as well, you know, call it I, and this is again, and this is over. And I wonder if this is going to be enough, right? So what if I say now for I, again, over, boom. Is it going to at least compile? Let's not run it, but that compiled. Okay, so that means here we should be able to do something like and for, which is I, again, over. And this is sort of like an epilogue of this thing. Right, so it's going to be and for. All right, so this is and for. This is again, this is over. And yeah, we're just doing it like that. We're just doing it like that. And invalid name and for, yeah, we have to provide all of that stuff in here like this. Boom. Okay, so the thing I want to do in here is rather interesting. I want to nest them somehow. To nest them somehow, I think I need a second variable in here. So we have I and j. And essentially, I don't want to lose this code. So I'm going to put it in here. So for j, we're going to have again 1 over 1. Then we're going to do and j, again 1 over 1. I'm going to do something like that. So, and essentially here, what we're going to be doing, we're going to be just adding them together. Something like that. All right, so it's going to be basically sum. It's a Cartesian sum, right? So we do Cartesian product, and then we sum up all of these things together. That's effectively what we're doing. It compiles. It in fact compiles, and it works. So, who needs C when you have FASM? You can have for loops in FASM. Who fucking needs your stinky fucking C? Just program an assembly directly. I'm fucking telling you. Absolute coding. Absolute fucking coding. You don't need C. Absolute fucking coding. I'm telling you. Any way to have again this kind of thing, I have no idea, honestly. Personally, I would like to never actually provide any labels in here, though. Okay, so Spearman was suggesting some weird ass shit as usual, and that's why I appreciate him. He was suggesting to do some string concatenation. I don't remember what exactly he said, but I think string concatenation could be useful in here in the sense that for the over tag we can just append it with over or whatnot. We can just append it with over, and I think that will basically reduce the amount of labels that we have to put in there, right? So essentially we can say something like a outer, right? So this is the outer, and here, and we don't have to provide this kind of thing. So this one is the outer. And this one is going to be inner. Is that what you what were you suggesting? Right, so I think that's what you were suggesting, I think. Furthermore, honestly, can we base the name of these labels on the name of the variable? Yeah, so we simultaneously actually kind of got the same idea. Can I just say I? And I just realized that I forgot to provide the upper bound, but it doesn't really matter. So this would have been actually ideal. Right, doing something like that is ideal and fucking based, honestly. This is fucking based. Furthermore, I is a label, right? So I is a label, so we can kind of base it on that, but I'm not really sure. So we need to take a look at the documentation and stuff like that. So labels, constants and labels. To define label name. Maybe we can take a look at the profile, right? Clear text. So what the fuck is that, for instance? Right, so what the fuck is the backslash in here? That looks sus, my friend. That looks sus. 4 is so based. Who needs upper bounds? You have jump. Maybe, but I think it would be nice to just have something like, let me show you, right, just from 1 to 10, right, so from 1 to 10, 1 to 10, I think that would be actually kind of cool. So let me see, I want to take a look at what is the backslash. Okay, so instruction syntax, any of the symbols is a character. Okay. The hash operator can be also used to concatenate two quoted strings into one. Okay. So that's really cool. Now, let me try some choice. So we're gonna say dot. Can we say something like that? Can we say something like that? So then later, and by the way, so let's actually not provide any bounds as for now. We're not providing any bounds in here, just to, you know, keep it simple and stuff. So it's for I and for J. So it's that, and this one is over. Chat, it's over. It's fucking over. Give up. Go home. I'm serious, chat. Alright, so we got something like this. This is actually kind of cool. This is actually kind of based, I would even say. A fucking based, mate. Let's try to compile this shit. I hate that this motherfucker compiled. Don't fucking tell me that it's also going to work as well. Fuck you, Leatherman. Fuck you. It worked. You can actually do that. Disgusting, honestly. The fuck? Just a second. I want to provide like a lower and upper bound. But the lower and upper, yeah, so the lower and upper bound is actually, has to be like sort of, yeah, provided in here. So low, upper. So this is the low, and we provide the upper in here. We can now do something like this. Right, so we can say, okay, from 1 to 10, print hello world scheiße. From 1 to 10, print hello world scheiße, and the message is, yeah, I can actually put whatever in here. Right, so, and then I can actually have nice for loops in here, and it makes too much. Oh my god! Fuck you. Are you serious? So what if 5? Well, I mean, it actually up until that one, so it's exclusive for the upper one, right? It's exclusive for the upper one. So, and obviously here, we probably want to also maybe move into RDI, so I, and just call print, like so. Yeah, and here are all these things, so I can maybe put this kind of stuff in here. Yeah, there we go. So 0, I can do that, and I can even nest this entire thing just by doing something like J and for J, and then just do something like that. Look at that. So it's actually 5, but I want it like 3. Right, so I have an outer loop, which does 5 iterations, and inner loop that does 3 iterations. This is assembly, by the way. This is assembly. So now I understand why their macro system doesn't really allow you to accept bodies, Because you're supposed to use the names of labels as sort of seeds, right? So essentially, if you have like a system of labels that cross-refer to each other, you're supposed to compose their names out of a single name, a single common name, like in our case, I, right? So from I, we use I as the name for the variable, for the index variable, but we also, based on that name, generate the again label and over label for all of this family of macros. Honestly, this is kind of based. This is kind of based, and I really, really like that. I really, really like that. So yeah, that's pretty cool. And furthermore, I can create something like a syscall macro. All right, so I can create a syscall, which it depends on how many arguments you want to put into the syscall. For example, this is the syscall of 3 arguments, right? So this is syscall 3, right? So this is basically a number, and here is the argument 1, argument 2, argument 3. Right, and in here we just like do it like that. Right, so here is that. So it's a syscall 3. Okay, so this is number. We move number in here. This is argument 1, argument 2, argument 3. And furthermore, now I can create a system which is the write, which accepts file descriptor, buffer, and length. So, and this thing is a syscall 3, 1, fd, buffer, and length. So now, instead of this kind of shit, what I can say is write 1, hello, hello, len, like this. This is assembler, chat. This is assembler. No. Damn, Brovsky. Absolute coding. Absolute fucking coding. It's insane. Absolute coding. So here, I would like to maybe have some things like, I don't know. So yeah, I think there is like std in number or not, like at least in C. I kind of vaguely remember there was a name. So do you guys remember what it was, like std in? There was a macro that's basically std number and file no. Yeah, I can never fucking remember. For some reason, it doesn't stick in my brain. Like it's number, it's file no, or like it's such a weird thing, right? So it's like, how do you even fucking remember that? So this one is gonna be so the input is 0, the output is 1, the error is gonna be 2, right? So this is basically what we want to have in here. So then later I can actually put like 1 in here, like that, so it's a little bit more readable. It would also make sense to maybe have something like a syscall for the exit, right? But that requires syscall for 1 argument. And I wonder, chat, if I can create like a generic syscall that accepts variadic arguments, and just depending on the amount of arguments, it just puts them there. I think I should be able to do that. I remember variadic Scheiße, meine Freunde. I remember the variadic Scheiße. So this one is 1. So then later I can just create something like a macro exit code, right? And it's a syscall 160 code. So then later I can say something like exit 69. Exit 69. So that's pretty cool. So, and it exited with 69 in here. Look at that. It actually exited with 69. That's pretty poggers. So we can also have things like sys write, which is just 1, right? So it's 1. So I can do sys write. This is a sys exit, which is 16, right? Exit 16. so we can have like a standard library at some point. And okay, the real question is variadic. How do I do variadic macros in here? So let's take a look. Variadic macros. Variadic. Yeah, so they don't call them variadic, but I do remember this kind of stuff, right? So char. They were talking about char. Yeah. Let's go to macro instructions. The section 233. The section 233. Let me see. Okay, there we go. So if after the macro directive you enclose a group of argument declarations in square brackets, it allows giving more values for this group of arguments when using that macro instruction. Any additional argument following the last argument of such group will start the new group and will become the first argument of it. For this reason, after the enclosing square brackets, no more arguments names can follow. The content of macro instruction will be processed for each such group of arguments separately. The simplest example is to enclose one argument name in square brackets. Okay, so you have struschar. So this macro instruction accepts a limited number of arguments, and each one will be processed into these two instructions separately. This is not exactly what I want. This is not exactly what I want, but I don't know. So there were also interesting instructions like that start with star, because remember there was something about star arguments and whatnot, but not exactly. Forward reverse command directives divide macro instructions into block, each one processed after another. So then you can say what is common, what is not common, and so on and so forth. Yes. Ooh. Okay. So the directives start the block. Yeah. So essentially, you reverse in a reversed order. You push arguments onto the stack. And then at the end you do a call for, look at that, this is actually kind of cool. Okay, so std call, you push them in reverse order, and this is what I wanted actually. Right, but this is, it makes sense because you're pushing them on a stack, but the syscall convention on Linux x86-64, you push them into these register, you add them into this register. So how can you do that? Obviously they thought about this like idea, right, that you can basically macro create a macro for calling functions, right, and don't think about like where to put arguments and stuff like that. But for Linux x86-64 it could be a little bit painful. GIF. How do you pronounce GIF, by the way? So here is the if condition. So this is basically what we were talking about. Okay, I need to understand how you use common. All right, if I pronounce GIF like if. I see. So forward, reverse, and common directives divide macro instructions into blocks, each one processed after the processing of previous is finished. Each one processed after the processing of previous is finished. They differ in behavior only if macro instruction allows multiple groups of arguments. Block of instructions that follow forward directive is processed for each group of arguments from first to last, exactly like the default block. Not preceding any. This is very this is very difficult to parse. Right, this is very difficult to parse. Something like just an example would have been better, and this is a very good example that just demonstrates how to do that. But more examples would be, I would appreciate more examples, honestly. So it's just like, it's really difficult to parse this like wall of text that instead of showing, just explaining a thing. Like, why are you explaining a thing that could have been just shown? Right, don't be, you know, a shower. Be a grower. Don't be a shower, be a grower. So it's kind of weird, But anyways, so we got this kind of stuff. What else can we do? We can maybe, since we have loops and shit, maybe we can process a file. Can we read a freaking file and just like, you know, iterate its lines and whatnot? I wonder. So when I'm parsing files, I like to have an abstraction which is called string view, right? Which is essentially a structure, right? So structure string view, and what this structure contains is essentially the pointer to the data and the size of the string view, so some sort of a count. And I do remember that FASM supported structures one way or another. So let's actually take a look at that. So structure, structure. Okay, structures. All right, struct, not even struct, but struct. It attack, but most importantly, it's struct. Struct directive is a special variant of macro directive that is used to define data structures. Macro instructions defined using the struct directive must be preceded by a label like the data definition directive, when it's used. This label will be also attached at the beginning of every name starting with dot in the contents of macro instructions. The macro instruction defined using the struct directive can have the same name as some. Show example. I don't want to get no time reading this shit. Okay, so here is example of structure of macro instruction. Okay, so I suppose it accepts some sort of parameters, so then you can initialize these parameters. That's honestly based. That's based. Okay, let's go ahead and fucking do that. Right, so we're gonna have a struct and we're gonna have a string view. So there you go. So and in here we're going to accept data and count. Let's call it PTR. Why did you fucking take all of the useful names? Fuck you. Address. Okay, so we're gonna call it address. Look, took all of the useful names that I could use in my structure, for fuck's sake. Anyways, this one is ADDR, and obviously both of them are going to be 64, right? So both of them are going to be 64, so I suppose it's DQ, right? And we initializing them with this kind of stuff, right? So, and this one is going to be a count, right? So this is the count, so it's pretty cool. So example, my point will define a structure labeled my consistent of two variables mx and so on and so forth. It also has the common and variadic shit. So that means it's kind of similar to flexible array members. So you can actually have flexible array members in FASM. Do you guys know that? Right, so it's so if you never heard about flexible array members, flexible array member, let me see. So it's essentially a structure that doesn't have a fixed size, right? So it has a sort of like a header of the fixed size, and then at the end it has an array of flexible length, right? I suppose this is kind of similar to that, right? So if you provide several arguments in here, right, they're going to be repeated, right? So because struct is a macro, so it can repeat its own body. That's cool. That's really, really cool. I really like that. So struct db, so you can specify, oh, this thing automatically, with this thing, you can automatically even have a size. And it's even cooler than flexible array member, because you know why? Because you can also have stuff after the flexible array member. Holy shit, this is more powerful than C. Right, because the thing about flexible array members in C, right, is that after the flexible array member, you can't have anything. Right, you can't have anything because you don't know the size of this thing. But in here, you can actually put stuff outside. So that's even cooler than flexible array members. It's more flexible than flexible array members. So that's pretty cool. Okay, so we got some more. There's a lot of subs. Holy shit. Thank you so much, Trefis, for tier 1. The Bainit, I hope I pronounced your nickname correctly. Thank you so much. Jerwayne, thank you so much for the Prime. The Bunny, thank you so much for gifting subs. Apocryphony, I hope I pronounced your nickname correctly. Thank you so much for tier 1. So that's pretty cool. That's pretty cool. But what I want is just to have like a string view, right? So we have a string view and we have a struct. And everything seems to be fine. So the thing I want to do now, I want to read an entire file, right? So the question is, how can we even do that? So we can have a function, a read entire file. So here we'll have to probably supply the arguments, probably just a file path, right? Thank you so much, Premoistant, for Twitch Prime. Thank you. And with the message, are you even getting any of these dollars? No, I don't get anything, and I won't get anything. So if you want to actually support me, you know, some way that actually gives me money, you can actually check out the donate command, right? So there's a link in there. Go into that donate command, and maybe that option is going to be convenient for you. If that specific option is not convenient for you, don't feel obligated to actually donate. Just saying. So use that option only when you want to actually support me. Right, so actually. So for now, subs and like on Twitch and Patreon, they don't give me any money, but they are convenient for people to donate, and I use them as a moderation tool for the Twitch and the Discord, right? So Discord is closed, and it's a very convenient moderation tool, so to prevent spammers to just join in and spamming, right? So just basically give $5, and then you'll be able to write, and it works extremely well, even though I don't get any money for that. So the only reason I'm accepting stuff from Twitch and Patreon is because it's a good moderation tool, even though I don't get any money from that. So yeah. That's basically the financial situation. So this is what it is, and this is what it isn't. All right, so read entire file. So first we need to open the file, if I understand correctly, right? So we have to open the file. Let's go ahead and fucking do that. Open the file. So this one accepts 3 things. So we're gonna be accepting stuff into RDI, right? So we already have file in RDI. So let's actually maybe document that. RDI file path, right? So this is the file path. And it's going to basically... What the fuck just happened? I didn't want to press anything. Why did you redirect me anywhere? Yeah, so it's going to be basically forward through into the syscall. So I don't even have to modify RDI, right? So I can maybe just put something like this, but it's already there, right? So essentially, RDI already contains file path. So the next one is going to be RSI, right? Move RSI, and we have to provide flags in there, right? So I don't remember what kind of flags we have to provide in here. So here's the open. So flags. So O create, yeah. So O read only, right? So I want to just provide read only, right? So because I'm going to be only reading this entire thing, and also the mode, right? So, and what's going to be the mode? I think I can just put mode as 0 in here. I don't really plan to use it for anything. So move, and it's RDX, right? So it's going to be 0. So then we're going to perform the syscall. Right, so we're going to perform the syscall, and the syscall in Rex, right, in Rex is going to return us something. And this is really interesting because Rex, we have to put sys open in here. So I suppose I can just use syscall 3 and just put all of these arguments in here. Why did you put it like that? That's really weird. Sys open, then read only, and then 0. Right. And also RDI. It's kind of weird, right? So because RDI is basically going to do something like move RDI, RDA internally when we actually expand this macro. But I guess it's fine, right? I guess it's fine. All right, so this entire thing obviously may fail. And the way we can check for that, we can just do CMP rex 0. And if it's less than 0, JL, right, we can basically jump to failed. Right, so on the failed is going to be somewhere down there. Right, so failed. And in that case, we can just actually just return, right? Because rex already contains negative values, so we don't have to do anything in here. So we just jump to failed, and then we can check for that failed down there, right? So that's one of the things we can do. All right, so we open this entire thing. Here it didn't fail, right? It didn't fail. But another thing we have to do, we have to probably, you know, figure out the size of the file. So how are we going to be doing all that? Let me see. I'm going to try to compile this entire thing, and obviously it doesn't compile. We don't have a sys open. Let's create a sys open super quick. Sys open. Right, sys open is 2. Right, and that's not the only thing that we need in here. We also need ordonly. Right, so this is what we need in here. We can actually figure out the value of ordonly by looking into the C program. I think we can also do unistd. All right, and then I can just do something like printf d ordonly. Right, so here we can return 0. So cc main c, and so read-only is not available. If I take a look at the open syscall in here, it's not available either. So what if I just say open? So we have to, oh, it's a fc until something, some stupid shit like that. Okay, we can put it in here. So can you give me, it's just 0. Okay, cool. I didn't know that. Thank you so much. So it is just 0. It is just 0. So the next thing we can do, we can try to open a file, right? So we can say read entire file, and we can provide the file, which is just, I don't fucking know, this file. And obviously it's not going to work, I think it's not going to work, but we should try nonetheless. Yeah. So because you can't just put string literals in here, you need to allocate that value somewhere in here, right? So input file path, right? So it has to be something like this. It has to be db, and it also has to be 0 terminated, null terminated. That's how it has to be. So when we read entire file, and this becomes input file path, right? So this is what it becomes. Okay, so a legal instruction, because this is not an instruction. Yeah, because it's a function call. And we could kind of create a similar macro to like a std call in here. We could kind of create that, but I'm still tempting. How can I just create this kind of thing? Right, I need to have a list of registers. I need to have a list of registers, and I need to map each individual argument to the list of registers, and then say that if the argument index that 1, use RDI, argument index 2, use RDX, and so on and so forth. You know what I'm talking about? Right? I need to somehow like zip together the list of argument and the list of registers for the syscall. So then I can have a correspondence between them. And what's funny is that you can, there is a syntax for list of registers. I remember that. There was something like, there was a syntax for that. I do remember. You guys remember? Yeah, this is what I'm talking about. Look at that. It's not really a list of them, but it's a set. Right? You can check that a certain operand is one of these fucking registers. Okay, but how can I take the variadic arguments and just sort of like zip them together? So then I can say, okay, so this operand goes into that, this operand could go into that, and so on and so forth. So it's just like I don't fucking know. So fast call doesn't exist. All right. So there should be maybe some sort of a documentation for these sets of registers. It's not even set of register, it could be just a set of symbols, right? So because we're simply comparing symbols, it doesn't have to be registers. We're just checking if this symbol is one of the other symbols. Essentially, it's like a Lisp. It's a compile time Lisp. That's what it is. Which is kind of funny, honestly. There's a compile time Lisp. Huh. Compile time Lisp. Honestly, I kind of dislike the current to-do value. I think it's kind of dumb, right? So what is the current to-do? Today is a casually programming assembly. I think I want to put something like learning flat assembler, right? So I think it's a little bit better. So we can even put something like this in here. Or maybe learning flat assembler macro system. Or maybe macros, right? So you can put this thing in here. Right, and then let's actually create a command, right? So let's create a command for that. So we're gonna just say that, but then we're gonna do something like say it at the author. But if you provided an input for the command, use the input instead of the author, right? So let's do at cmd today. And that should create the actual command in here. So now if you do today, it will tell you learning flat assembler macros, and we just redirect to this kind of thing. So as you can see, our bot has a special language with which you can actually program it, right? So it's a simple sort of like a scripting language. So that's pretty cool. All right. So this is basically the current to do. So they're talking about this kind of stuff. This is a less operator. Okay. There's also operator that allow comparison for of values being any change of symbols. The EQ compares whether two such values are exactly the same. The in operator checks whether given value is a member of the list of values following this operator. The list should be enclosed in triangular bracket characters. Its members should be separated with cause. The symbols are considered the same when they have the same meaning for the assembler. For example, P word and F word for assembler are the same, and those are not distinguished by the above operators. In the same way, 16 is equal, okay, is the true condition, however, 16 equal is not. The same meaning. The Q-type operator checks whether the two compared values have the same operator. So enclosed in this, so it's a list of values. The way the growing list of symbols can be defined. Directive list of symbols. The IRPS directive iterates through the given list of symbols. That is pretty cool. So there is a special direct, okay, so you can have a list of, okay. So the IRP directive iterates through all the values that were assigned to the given symbolic variables. It should be, I think it's, yeah, I think it's in this place, RP value, okay. That's very interesting. So you get the list of these things, but then it doesn't zip them in a classical sense. There's also iterate, and see it, iterate. There's no such thing as iterate. Chat is hallucinating again. Okay, so yeah, I don't think it's gonna be that useful for me. So it's a symbol, so IRP is just that. Iterates the single argument through the given list of parameters. The syntax is IRP followed by the argument name, the comma in the list, the parameter can be enclosed character. Also, the name of the argument may be followed by to mark that it cannot get an empty value. I still don't know how to actually use that stuff. All right, so yeah, so we need to read an entire file. We need to read an entire file, and so we have to move this thing into RDI. Right, so we're moving this thing into RDI, then we call read entire file. Then we need to compare args into 0, and then we have to, if it's less or equal, then we fail, right? So maybe we can say fail read entire file, right? Fail read entire file. So here we can just exit with 0, and here we can exit with 69. Fail read entire file, and in here we just need to print something. We can do write std error. By the way, this has to be std out. What the fuck? Excuse me. So std error and failed. This one message, right? And this is the one that is the message length, right? So now we have to define it like this. We have to say could not read main asm, right? So I couldn't read this specific message. So that's basically what we're doing here. So for now, I think I'm gonna comment out this entire stuff, and in here I'm gonna just like write std out file number okay message length, right? So, and honestly, it would be kind of nice for all of these messages to have a special macro, which also gives you the size. I do remember this one, right? So the struct db. Yeah, that would have been super, super nice. So in this thing will define you the data and the size. Which so it kind of overrides the existing DB, doesn't it? Wasm is the best assembly, but you can't debug it with GDB, I think. Yeah, it doesn't generate any debug information, unfortunately, like NASM, for instance. NASM with -G, it can generate like a dwarf file or something like that, or maybe like a different kind of format. And then you can do it with GDB. But I mean, you can still use GDB, but you don't have a mapping from the assembler to the source code, fortunately. You can make a macro for defining strings, which would automatically also define name length. Yeah, this is exactly what I'm looking at, right? I'm literally looking at this macro. Right, so I know about this macro, and here it is. This is how you do that. So, and I'm just thinking, like, why did they call it DB though? Right, because it's kind of dumb, in my opinion. It's kind of dumb, but it is what it is. So anyway, by the way, for sys write call, you don't need multimedia. Who fucking cares? It works even with it. The code is not broken. Who fucking cares? All right, so now let's actually see. Like, I'm not really sure if I understand this code correctly. Right. Why it is like that? Right? Why it is like that? It behaves the same as DB, also defines one more symbol. I don't like that they override DB. That's the thing. So they're doing some really sus shit, overwriting a standard, like changing the meaning of the standard name, and they don't seem to be providing any justification for that except, oh, you can do that. It's kind of, it makes me anxious, right? What are they trying to say, like, with that? So you're trying to say that the actual DB behaves like that? Or, like, it makes me really anxious. Why didn't they create a separate name for this macro? Like, it's like, why? Like, it's so weird. Like, why would you do that? If it's a different thing, fucking give it different name. Don't confuse the reader. Like, why? It's so bizarre, because, like, I don't know how to interpret that, right? So how am I supposed to interpret that? Anyway. So common DB, and also why do you put dot with a space in here? Restruct diagram was the last definition of a structure. I don't like this. I really don't like this example. I don't want to use it because it's really hard to understand. It's really bizarre. I don't like it. I'm not going to be using it. All right. So, okay. So what I want to do is just test some stuff. So we are writing OK message. And I'm going to be actually manually doing this kind of shit. Right. So I'm going to be manually doing this kind of shit. So this is that. All right. Okay. Just because the example is weird, I'm going to be doing that manually. They could have provided a less weird example, and it will be more helpful. But they decided to be less helpful. So it's on them. It's on them. Don't blame me. All right. So, and then here we just do exit, yeah, 0. Okay. So let's just try to run this entire thing. Okay, message is not provided. Okay. Okay, message. This one's DB. Okay. I'm gonna just put 0 in here just to piss you off. Right. So whoever said in chat, I'm gonna put 0 everywhere. Right. So from now on, it's gonna be 0 everywhere. Because it doesn't break anything. It literally doesn't break anything. So okay. So illegal instruction, yeah, this is, well, I mean, technically it may break something though. It may break something because there's an extra 0. But I mean, why not? Let's actually print extra 0. Who cares? Yeah, so there will be extra 0 in here, but who cares? We're gonna put it in there because it doesn't obscure the logging, right? You still can read everything, so it's fine. It would be kind of nice to have like a new line. So let's actually put a new line after the 0. Yeah, so because it's kind of difficult, right? So if you have several messages in a row without this extra new line, it's kind of difficult to read all of that, right? So I can actually do it something like this, right? So as you can see, it's ok, ok, ok. Look, we need to separate that with new lines. So I'm going to put a 0 in here intentionally, and then a new line after the 0. So now, as you can see, they are separated with new line. It's fine. It's readable. Nothing is broken. Looks a little bit weird, but nothing is broken. It's working. Right. So this is how we're going to be doing things from now on. So here's what it is. Now, so the fact that it's printing OK, by the way, means that we successfully opened the file. Right. So we successfully opened the file. If we change the name of the file, it should actually return could not read main asm, right? And look at that, there is a 0 in here. And it's always going to be 0. It's always going to be there. I'm going to be, from now on, defining all of my string literals with an extra 0 at the end. And there's nothing you'll be able to do about that. I'm sorry. So there will be always extra 0 in here, period. Anyways, so I also really like that Emacs shows that extra 0. Yeah. So null terminated strings. Null terminated strings. Okay, so we managed to open this file. We also need to now read the, somehow figure out the size of the file, right? So, and I do remember there was like a stat, I think it was fstat, if I'm not mistaken, right? And the problem with the fstat is that it accepts an entire freaking structure in here, right? So that's a little bit of a problem. Just to figure out the the size of the file. So, but I don't know. Maybe we can just allocate a buffer big enough for a file to fit, right? So we don't have to spend time figuring out the size or anything like that. So let's just allocate a big enough buffer. Right, so this one is going to be buffer, and it's going to be reserve bytes, and let's reserve, kilobyte. So how big? Oh, it's actually 2 kilobytes. Okay, so can I allocate like maybe 10 kilobytes? Right, so that should be enough for anybody. I'm pretty sure. Right, so let's try to do that. Okay. So that seems to be a good, buffer capacity, so buffer cup, and it's going to be minus buffer, right, there we go. So we should be able to use the buffer capacity. So in here, we're gonna do sysread. Let me define the sysread thingy. So it's actually 0, right? So it's a read, write, open, and there you go. So it's something like that. So yes, so we're gonna do syscall3 sysread, and yeah, this thing should return you the file descriptor, right? So and it will return you in the racks. Excuse me. So where are we going to be allocating this entire shit? Look at this thing. Where are we going to be allocating this entire shit? We can allocate it on the stack. Right. So we can maybe push, you know, RBX, right? So we can push RBX. So by saving the previous stack frame onto the stack, and then we can move RSP, like RBX to RSP in here. So this is a new frame stack. Do you guys know what it's all about? I guess we're about the stacks and shit like that, because it's kind of a fascinating thing, right? Because how these stacks work on modern computers, like at least on x86-64. But as far as I know, stacks work similarly on the on ARM as well, right? And it's kind of like a common thing in the modern computers. So essentially, stack allows you to basically have nested calls, and within those nested calls, you can have some arguments, right? Usually, right? So here is the stack. So did I? Yeah. So I modified everything properly. So, okay, so when you call a particular function, the return address is saved on the stack, right? The return address is saved on the stack. Then within the function, you can have a bunch of arguments, right? So you can have a bunch of arguments and stuff like that that are local to this particular function call, right? Then you can call it again, and it's going to have another return address and so on and so forth. So then when you return from a function, you deallocate the arguments that you allocated in here, and then you use this return address to return back to function from where you call that. Then you can deallocate that and return back and so on and so forth. It's actually a very useful thing, right? So you just like have a nested call stack. But in reality, it's actually not implemented like this, like at all. It's not implemented like this. It makes it look like the stack is growing from like 0 towards infinity. This is not true. On x86-64 and also on ARM, and also on WebAssembly, by the way, right? So on WebAssembly, there are two stacks. There is a stack of arguments, which effectively acts like registers, but there is also a stack generated by LLVM, right, to emulate C runtime environment. So usually in the memory, right, you have 0 somewhere here. You have 0 somewhere here. And stack base usually starts somewhere here. So this is where the stack starts, right? So stack, where is my fastest stack? No, base or whatever. I don't know how properly it's called or anything. So when you push a number onto the stack, you actually decrement this stack pointer by the size of the number, usually 64 bits, right? And you store this value in here. The stack grows towards 0. The stack just grows towards 0. So essentially, if you call a function, right? If you call a function, so it's better to call this thing RSP because, you know, usually this is where the, you know, the stack is stored, right? You push a value onto the stack, the RSP becomes this, right? So the RSP becomes this. So if you call a function, right? So the return address for the function is stored on the stack, and RSP becomes something like this, right? Becomes something like this. Why doing stack like that is actually useful? Because then whatever value you pushed in there, you can just read that value from RSP directly, right? Because look at that. So you're reading values from left to right, and it points exactly at the beginning of this value. If you were pushing the values from left to right, your RSP would have been pointing at the after the value. So to read that value, you would have to subtract the size of the value and only read that. You kind of have to read backward. But here, since you're pushing sort of like towards 0, it's actually super easy to read the value that you just put in there. So you see what I'm talking about? It's it's 200 IQ move. It's actually super cool, right? It makes sense when you think about this kind of stuff, right? So let's actually say that the stack starts in here, right? So stack starts in here, right? So, and essentially, once you call the function and you have the return address in here, you can then very easily allocate local arguments in here, right? So you can allocate local arguments in here, right? You can use them, you can address them like as it is from left to right, and then when you're done with them, you can deallocate them, and then you can pop the value out of the stack and return back, and so on and so forth. But here is an interesting thing. So let's actually extend the stack a little bit to the left, right? So because we don't have enough space, and 0 is somewhere there. So as you are allocating and deallocating things within the stack is kind of like wobbling around. Like this RSP motherfucker, it is constantly fucking wobbling around, right? Even though it is very useful to read the values at the top of the stack, this motherfucker is so fucking wobbly, I don't have a stable address for my variables. Like I don't have a stable address, like I allocated some variables and then some other code, some pushed another stuff onto the stack. Like where is my fucking variables? I can't find them on the stack. So because of that, you kind of need like a more stable address from which you can like read things, right? And this is where the RBS, right, comes into play, right? Or maybe RSB, right? So it's basically base. So as soon as you like pushed the return address onto the stack, you also mark this specific place as is it RSB, right? RBP, yeah, it's RBP. Thank you so much. So as RBP. So now you can allocate more local variables in here, right? And your RSP can wobble around however it wants. I still have a stable RBP from which I can actually find all of my local variables. So RBP, I believe it stands for R extended base point. Yeah, maybe. Anyway, so this is basically what it's all about, right? So you basically start a particular function call, you save sort of like the base where your local variables start, and you can allow this thing to wobble around and stuff like that. Right, so, and this thing, right, so, and the more you have function calls, the more these sort of like stable pointers you have, and all of these things are usually called stack frames, right? So that's what we usually refer to when we talk about stack frames. Right, so that's basically like stack 101. At least this is how I understand it. Maybe I'm understanding it correctly, but I mean this kind of mental model worked for me. So anyway, we got some bits and stuff like that. So thank you so much, Anonymous Gifter, and thank you so much, Hector HS. So I used to love you. Do you see on the moon ice? I don't know what you're talking about. Just a poem. What are you trying to achieve today? I'm just programming in Fuzzy. Thank you so much for the bits. All right. So yeah, essentially I'm saving. It's not really RBX. It's RBP, right? So yeah, I'm saving whatever was the previous base, the previous frame. Then I'm establishing the new one in here. Right, and so that means I can now allocate some things. I can maybe even save some stuff in here. For instance, I can move, right, so I take RBX, right, so RBP, I mean. I subtract 8, which is the size of 64-bit integer on the stack, right, and I just move racks in there. So which is a file descriptor. So now I know that the racks, the file descriptor is located in here on the stack. So when I'm going to be returning out of this entire thing, I should not forget to, I suppose, yeah, deallocate everything, maybe pop RBP, right? So we didn't really modify RSP in here, did we? Well, we probably should, right? So if we're going to be calling inner things, we probably should modify some stuff, but yeah. So might as well just say subtract RSP 8. So this is how much I allocated in there. So then I add RSP8, then I pop RBX and then return. Did I do everything correctly? I think I did everything correctly. So that's how basically you allocate. You just save this thing, then you set the current RSP as the base point, and then you kind of allocate it. Right, so then you deallocate this thing, and then you pop RBX, and then you use return address. And you kind of want to do that for both of these things, right? So since these things are the same, might as well just do it like this. Yeah. Might as well just do it like this. Okay, so we have a file descriptor, and now what I need to do, I need to read the whole thing in here. Right, I need to read the whole thing. So it's going to be sys read, and we are reading RBP -8. So this is the file descriptor. The buffer we are reading is this, and the capacity of that buffer is the buffer capacity. So then, if the result failed, we go into failed immediately. We don't even think about that. So then, if it didn't fail, rax should contain the size of the file, which we might actually save somewhere here. So we can do buffer length. So we have a buffer capacity, but this one is buffer length. And I might even allocate like a DQ, right? So it's going to be initially 0, but I mean, I can reserve that. I think reserving this thing is much better, right? So I'm reserving 1, right? 1 quad word. So that means I don't really need string view right now, right? I don't really need it, but maybe I'll need it in the future. We'll see, we'll see. So, okay, so this is read. We read the whole thing. So rax contains the stuff which I want to save into the buffer length. Can I just jump back? Thank you so much. So I move this value in here, so it's now in buffer length. Afterwards, I want to close the whole thing. So I want to do syscall1, sysclose, and I'm just closing this file descriptor like this. All right, so when I close this, okay, so this is just that, and sysclose is 3, right? Sysclose is 3. Let's put it in here. So here is the sysclose. Right. And that's about it, honestly. That's about it. Do we need to return anything in here? So yeah, so if sysclose fails, it's gonna fail the whole thing anyway, so we don't have to worry about that. All right. Okay, cool. Syscall 3. Oh, okay. All right, so let's fucking go. It's invalid operator. This is because I have to use an address of this thing. There we go. Could not read file. Cool. I wonder which one, and I wonder why. So maybe after that, we have to move rax to 0. Oh yeah, that makes sense, right? So because maybe syscall didn't modify the whole thing. No, it actually fails somewhere here. CMP rax. Okay, so let me try the following thing. So we can actually try to debug all of that. Let's go ahead and simply debug. I think it's going to be useful. So let's put a trap in here. Right, so trap has been like triggered. Let's do gf2 and let's run the whole thing. And what I have in here. So we push RBP, we allocate some stuff, everything's fine. So the next thing we need to do, we need to open the file. We're opening the file. Okay, so I'm populating all of these things. Boom, we've got the rax, right? So we're just comparing this entire thing, and we didn't, like, nothing really happened. So then we save the rax to the stack, right? So it would be kind of nice to maybe know what's on the stack, right? So we can always take a look at the RBP, right? So here is the, I can't even press RBP, I don't remember. Is it like this? Yeah, so here it is. So here's the RBP, and I can subtract 8 out of the RBP, and then I can kind of treat it as a pointer to long int, actually, maybe even unsigned long int, because it's a file descriptor, or maybe just int, I don't remember. Yeah, let's actually treat it as that, and then I can dereference this entire thing, and it's 3. right? Which is, you know, fair, It's a file descriptor. So, okay, I'm just doing rex, so it's 0, so the syscall 0 is, it's not really syscall 0, it's a read. Okay, so we do read, then we're loading into RDI the file descriptor, then we providing the pointer to the, what is it called, to the buffer, and then the capacitor of the buffer. Right, then we perform the syscall, and rex actually gives us how much we managed to read. Right, so if it failed in here, so yeah, so it didn't fail. All right, so then we're moving the size into the length, right? So okay, so it's moved into the length. Then I'm moving. Okay, so I think I found the fucky-wucky. Syscall 1. So then we move in 0.3, this is close, okay, so this is close, and then into the RDI we move in the file descriptor. So RDI does contain file descriptor, so, and then I do, so it's fine, okay, and then I return. Why is this JLE? Who put JLE in here? It has to be less. Yeah, so that's why it failed. Might as well actually just ignore the whole thing in here. Just like literally ignore. I didn't think it matters to check. Well, I mean, it kind of makes sense to check it in here, but anyway, I think that was the problem, right? So it was just rex is already 0 and it could be equal to 0 and it just, okay, so I found an error. You see, debugger is useful. Debugger is useful. It's actually useful. Okay. So in here we do syscall, right, and obviously, right, so the whatever sysclose will return, it will return. So in here it will return okay if I try to do that. So let's find int3, so let's remove that, and it printed okay. Look at that, it actually printed okay. That's pretty cool. So, but we probably want to print the content of the file, right? So it's not really useful to print okay. Let's print the buffer with the buffer length, right? So this is going to be buffer, and the buffer length is buffer len. Let's go. Let's fucking go. So boom, and it printed itself. We implemented Quine, everyone. We just implemented Quine in assembly. How about that? How about that? Yeah, it's a cheating Quine though. It's pretty much a cheating Quine. Cheetah Quine. Quint. How can you count the amount of freaking lines? Honestly, you can just allocate count dq0. Right, now let's just fucking iterate that, mate. Let's just fucking iterate. So for I, from 0 to the buffer length, and for I, we can be iterating the buffer. So I'm going to just move rex buffer, then I'm going to add rex I, right? So I'm just adding that thing there. Then we can, so rex obviously right now contains a pointer, right? It contains a pointer to character. So, and it's kind of a stupid way to do that, right? So usually in assembly, what you want to do, you want to just have a single address and you increment that address, but I just want to use the for loop macro in here, okay? Right. So I might as well also move count 0. So let's actually 0 initialize the count in here that we got. Right, so I add this specific address, and then I want to read from that address. How can I read from that address? Maybe I'm going to do rbx, maybe just like bl rex, and I'm just reading like 1 byte from here. I'm reading that 1 byte. And is there like a conditional increment in here? So essentially what I want to do in here is just like a bl compare it to a new line. right? So I want to compare it to new line, and the new line is 10, right? So we can just use 10 in here. Is there a conditional increment? Does anybody know? So there is like a move something something. So x86-64 conditional increment, right? Because I don't want to be messing. Is increment an atomic? Nah. C move, yeah, something like C move, but C inc. I know about C move, but I want C inc. Move if above, move if carry. So x86-64 C inc. So I don't fucking know. Kinky, yeah, kinky. We can kind of read RCX count, right? And then we can increment RCX. Then we can do C move. Then we just perform this kind of thing. And then C move x86-64. Okay. C move equal, yeah. C move count or C. Is that too dumb? Is that a divine intellect or not? Okay, like I know that it's a not really, you know, good assembly code, especially written manually, but it's an assembly code, right? So we initialize the count, right? We take the buffer, address of the buffer, we offset the address of the buffer by the current I thingy, right? So we offset it by that. Then we read a single byte out of that into BL, that's fine. So we load in RCL, like the value of count into the RCX, and we pre-increment it. Then we compare BL with the new line. And if it's equal, we are assigning the incremented RCX to the value in count. So is that a divine intellect, chat? Please tell me this is divine intellect. You can't move into memory. We'll see about that. We'll see about that. Oh, fuck, you can't do that. Shit. So it's actually complaining about something in here. So invalid operand. It's a CMP. You can't compare. Oh, shit. It's something inside of the thing, actually. So 40. Let me see. You can't compare memory per se. That's the problem here. You can't compare memory per se. I wonder what we can do. Can we just do something like pop? Okay, you can push racks. You can move this thing into racks. Then you can do racks. Then you can pop racks. Something like that. Can we do that? Okay. Yeah, you can't do it like that. Okay, so you can't move it. So we have to come up with something else. I wonder why though. Though we can, yeah, I can use RDX, I suppose. So here's the RCX, and we can also move RDX. Do you think this will stop me? You really thought this is going to stop me, right? So you really fucking thought this is going to stop me. So I'm going to move RDI count, and then I'm going to call print, right? And it's going to give me the amount of lines. Going to give me the amount of, oh, fuck. So operand size not specified. Okay, so where is this shit? It's going to be a keyword. I'm really grateful that it tells me this kind of stuff, so it's type safe. Okay, so it compiles. Let me go through this entire shit one more time. So here's the buffer. I have said by the index of the buffer, I read this entire thing. Okay, so we take the current counter, we put it into RCX, but we also duplicate it into RDX, and we pre-increment RCX. So then we compare the red byte with the new line, and if it is in fact equal, we're moving the pre-incremented RCX into RDX, right? And we always move that thing into there, though there is no branching in here. Look at that. So maybe it's fast, right? So maybe it's fast. So anyway, that should work. And then we move the count into RDI, and we just simply print it. So let's go ahead and just do something like that, and it's 176. Is that true, chat? Is that true? It is in fact true. And it's all implemented in assembly, in Phasm, to be precise. So we don't even have to maybe print the buffer, right? So CMove is slow compared to conditional jump. You're just mad that I'm sitting here actually writing code and you're sitting there in the chat just backsitting. You're mad that you're just writing words, I'm writing code. Stay mad in the chat. So so this is actually kind of cool. This is actually kind of cool. Phasm assembly is pretty based. Phasm assembly is in fact pretty fucking based. Do you guys want this code? Do you guys want this code? It's kind of shitty code, honestly, right? So it has like a limited capacity of the buffer. What would have been cooler is that read entire file would figure out the size of the file and then pre-allocate the memory. I'm writing an assembly right now. You have zero proof. Here, I'm recording myself writing assembly. You're just saying things in the chat. Anyways, so yeah, I guess that's it for today. Thanks everyone who's watching me right now. Really appreciate it. Have a good one, and I see you all on the next recreation programming session with Mr. Azuzin. I love you. Mwah.